Welcome to The Explainer. Today we are tearing down a massive illusion in modern software development. I want you to stop for a second and think about exactly how your engineering team is measuring its performance right now. If your DORA metrics are living in some massive shared spreadsheet, or if they rely on someone manually updating them in a weekly stand-up, well, I've got some tough news for you. They are completely wrong. Because relying on manual updates means you aren't actually measuring reality, you're measuring human memory and developer optimism. And let's be honest, that is basically science fiction. Real, actionable measurement demands automated instrumentation. So today, we're going to fix that.
We've got a lot of ground to cover, so here's our roadmap. First, we'll look at why your metrics lie. Then, instrumenting the 4 metrics. Third, what to fix first. Fourth, we'll hit some common data quality mistakes. And finally, tracking versus actually using DORA. Let's get straight into the framework.
All right, part 1, why your metrics lie.
Look, it really is this simple. Manual stand-up updates equal wrong data. We have to boldly declare right now that real DORA measurement requires automated instrumentation at 4 specific points in your pipeline. Because the second there is a human anywhere in the chain manually inputting these numbers, the data instantly becomes political rather than factual. It's human nature. Teams naturally want to look good, right? So the numbers get subtly rounded up, delays get justified away, and suddenly you're reporting these beautiful metrics without actually instrumenting the real, raw data sources. Think of this explanation as your hands-on platform engineering implementation guide.
Okay, let's dive into exactly how to do this in Section 2, Instrumenting the 4 metrics. We're going to start with metric number 1, deployment frequency. Now, there is a massive myth floating around that you should just count your merged pull requests. But merging a PR absolutely does not mean value has been delivered to your user. The reality? You have to count successful production deployments. To wire this up correctly in a tool like GitHub Actions, for instance, you need to emit a deployment event only when your production job completes with a green success status. If it fails, or if it just deploys out to a staging environment, it does not count. Once you capture that verified success status, you're going to push it to Prometheus using a push gateway. But here is the absolute critical detail. You must label these events by service and by environment, not just by the team name. Pushing these tagged success events is literally what empowers your teams to drill down into their Grafana dashboards by specific microservices. It's like a magnifying glass. That is exactly how you spot which specific service is dragging down the whole team's deployment frequency. Next up is lead time for changes. A really common mistake here is measuring lead time starting from the moment a PR is merged. But think about it. If you do that, you are completely hiding your slow review cycles. And the review cycle is almost always the exact bottleneck you need to uncover. Instead, you've got to measure the total time from the very first commit on a branch all the way to the moment that specific commit is actively running in production. So how do we automate that gap? Well, you need to pull 2 specific timestamps and store them in a time series database to calculate that delta. First, you pull the commit.author.date from the GitHub API the moment the PR is opened. Second, you record the deployment.completed@at timestamp directly from your pipeline right when the job finishes. The difference between those 2 points in time? That's your true lead time. By storing both of those in your database, you get an unarguable, fully automated measure of how long it really takes for code to go from a developer's keyboard to the customer's hands. Moving right along to metric number 3, change failure rate, or CFR. The formula itself is super straightforward. It's just failed deployments divided by total deployments. But honestly, the math isn't the hard part here. The hard part is enforcing incredibly strict automated rules on what actually constitutes a failure. You simply cannot rely on someone shrugging and saying, oh, that was just a minor UI bug. It doesn't really count as a failed deploy.
To enforce this, here are the 2 exact triggers you need to automate. First, if a rollback is triggered within 1 hour of a deploy, boom, that is an automatic failure. Second, if a PagerDuty incident is created and linked to that deployment window, that is also a failure. You do this by linking incidents to deployments using deployment markers. If an incident opens within your configurable deployment window, say a 60-minute window to start, your system needs to flag that deployment as a failure automatically. No debates, no human intervention.
And finally, the 4th metric, mean time to restore, or MTTR. Let's be real, MTTR is universally where teams have the absolute worst data quality. Trying to pull MTTR from human memory or making rough estimates after a highly stressful outage, that is a terrible idea. The fix is actually pretty simple. You have to pull it directly from the PagerDuty API or whatever incident management tool you happen to use. Here is the exact automation sequence for getting that MTTR tracking right. Step 1. Connect PagerDuty to your metrics pipeline using a webhook or a scheduled API poll. Step 2. For every single resolved incident, automatically calculate the gap. That's the resolved at time minus the triggered at time. Step 3, and this is absolutely crucial, filter that data to only include P1 and P2 incidents. Why? Because the sheer noise from low-priority P3 or P4 alerts will massively distort your classification when you're trying to figure out if you're an elite or just a high-performing team. Step 4. Push this clean data to Prometheus with your service labels. And remember, average this out weekly, not monthly.
Let's move on and see how this all builds together in Section 3, what to fix first.
You can't tackle everything at once, so this is your exact priority order. Number 1, instrument your deployment events. This is your leading indicator. Low deployment frequency almost always causes poor scores across the board, and literally everything downstream depends on this being accurate. Number 2, wire up your PagerDuty MTTR. This gives you the highest, most immediate ROI for leadership visibility. Number 3, add your lead time tracking to finally expose those hidden review bottlenecks. And finally, number 4, calculate your change failure rate last. You literally cannot calculate an accurate CFR until both your deployment data and your incident data are totally clean and automated.
Now, before you start building, let's talk about Section 4, common data quality mistakes.
Let's rapidly punch through these pitfalls, because they will absolutely kill your data quality. First, counting PR merges as deployments. Remember, only production actually matters. Second, including all PagerDuty incidents in your MTTR. You've got to filter by production and severity. Third, relying on monthly averages. A monthly average totally hides regression patterns. You need to review this on a weekly cadence to surface regressions before they snowball. Fourth, having no deployment markers in your APM or incident tools. Without them, you literally can't link incidents to specific deploys. And finally, the ultimate sin, manual data entry anywhere in the chain. I'll say it again, automate it or the data becomes political, not factual.
Which brings us to our final paradigm shift, Section 5, tracking versus using DORA.
DORA metrics are not a reporting exercise. They're a feedback loop. That's the golden rule here. When your pipeline emits deployment events automatically, and when that PagerDuty MTTR flows straight into Grafana without a single human touch, something truly magical happens. You stop debating the numbers. You stop arguing in meetings about whether you're actually improving. Instead, you start looking at your real-time dashboard and finding exactly where your real constraints are.
So, I'll leave you with this provocative final thought. Are you tracking DORA, or are you actually using DORA? Because if you're just tracking it, well, you're really just filling out a report card. But if you're using it, you are actively leveraging an automated feedback loop to remove constraints and deploy better software way faster. Take a really hard look at your pipeline today. Rip out those spreadsheets and start instrumenting reality. Thanks for joining me on this explainer, and keep learning.